So today we will see natural language programming. Sorry, processing. Natural language processing. So to be honest, this is a very huge subject. Rather, um, this is a area of research in itself. Everything that we see these days, like ChatGPT, your LLMs, Siri, or all these things comes under natural language processing. Even the language translation, Google Translator that we see, all are kind of natural language processing. So we want so to handle an NLP problem, there are two methods that we can use. One is machine learning way, and one is the deep learning way. So there are two ways we can solve it, either machine learning way or deep learning way. So in the machine learning, again there are two types. One is supervised and another one is unsupervised. So example of this is sentiment. So the thing is, NLP is a vast subject itself. We will be seeing a small part of it. We won't be completing the entire thing. But what we will do is we will just get the gist of it, like what goes into it, and what kind of um, how basically it is um, solved. But we will be doing it only machine learning way. Deep learning way, so all the chatbots and everything that we see today, they use deep learning. They do not use machine learning because machine learning has a limited uh, accuracy. So uh, machine learning models have limitations in case complex inputs such as the text or prompts that you are referring to. So uh, they current all the current models that you see use deep learning. But so so just to summarize, so just to and even to give some few examples, basically why we started to think in the line of NLP. So on social media, let's say on Twitter or X, if someone writes a hateful comment, right, or a false news, or yeah, or a hate speech, and people started retweeting, reposting it, then so then it is it is very quickly it has a potential to spread a wrong news, like we have recently seen this example. So we would like a model that can classify, detect the false information from the true information, or it can detect the hateful speech, it can detect the abusive content, or it can detect the content that is uh, limited to a certain age group. So in order to classify things like that, uh, we would like um, we would like a model which can detect it, because uh, it's very easy for a human to classify this. It's easy for a human to say this is hateful speech or not, if this content is harmful or not. But for machine to do it, it's difficult. But why we want a machine to do it is because it can do it at a scale. Let's say, uh, let's take an example of X. Daily there would be 1 lakh, let's say, tweets or posts on X. But can a human identify those, let's say, in 10 seconds, all of them? If we want to analyze all of them after, let's say, 5 seconds of the post, then it cannot be done by human. So if we are thinking of a problem at such a scale, it is important for us to have a automated process, because we cannot employ that many people to just to go through it. And even if we employ, we cannot ensure that all will be all processes will be done in few seconds. So if we are thinking of a problem which is at scale, you need to have an automated process. So that's when people started to think about NLP model. So people, so that people will understand the intent behind the message using an machine learning algorithm. So chatbot, Siri, and content summarization are some examples that I can think of for NLP. So you might have seen, if you Google search a movie, there would be a tab called review, right? So people on the Google give reviews. People on the Google give reviews, right? This is user one, user two will give some review. And what Google do for you is it summarizes all of this and then understand the emotions and tell you the review, like it is heartwarming, and then it is funny, things like that. So it will just summarize the entire content that people have said into some few words. How does it do that? It to do with NLP. Okay, so NLP is very broad area. Solving People solve, uh, there is a lot of research going on, and there are two methods to solve it. One is traditional machine learning and another is deep learning. But we won't get any state of art results using machine learning. For that, we will always need to go for deep learning. Okay. Using machine learning, our results are gonna be limited. So this is a limitation. But even with machine learning, we can achieve results in certain areas. So let us start with one problem. We will start with the sentiment classification. So first, let's say you take a input. Let's say we are analyzing the review. So let's say the data is like this. So first you will see a supervised learning. What is a supervised learning? Supervised learning is when you have your both X and Y. So you have the data and you have the expected class. In unsupervised learning, you only have the X. Y is not given. So machine learning starts with uh, X only and it predict the Y. We will see one example of this as well, but let's start with the sentiment class. So any doubt till now? Any question till now?
Fine, fine, fine.
Okay. So we will do a sentiment classification. So let's say there are some reviews and there is a sentiment. So if the review is good, your sentiment is positive. If the review is bad, then your sentiment is negative. So there would be reviews. Based on the review, your sentiment is going to be either positive or negative. So what we will do is our input will be a review. Okay. We will feed that to a model, and then it will tell us if the review is positive or negative. Okay, problem statement is clear.
Yes, yes.
So actually we have, this is a classification problem. Okay, we have many models like we have logistic regression is there, decision tree is there, uh, k nearest neighbors is there, tagging is there, then random forest is there. So but can we use this directly? So can I just pass the review through this and get this? Yes or no?
No.
Why not? Your answer is correct, but why?
Since it's difficult to judge like
Sorry.
how to separate input review like
Okay, I understood what you want to say. So you want to say that for machine it's very difficult to understand what a sentence is saying,
yeah,
right? Yes,
correct.
but yes, that is correct. It is very difficult for a machine to understand what it is doing, like what the sentence is saying. But one thing is, for these models, you need a numerical input, numerical or numbers as an input. So if you directly throw a text into these models won't do so won't perform well. So what you want to do is, so there are two options that are left with us. Okay. So so one option is find a new model that directly analyzes text. And second thing is we can convert text into numbers. Sorry. And use the existing classification algorithm. So there are two ways in which we can do this. Either find a new model that analyzes the text directly, or what we can do is we can convert the text into numbers, and then from there we can use any of the existing models that we already have. So uh, which method you will use?
Forget.
Sorry, no, just a guess. I'm not asking, like, I'm
No,
not expecting you to
in
know. Hmm.
above classification you are asking.
Yeah, no. In any, in above, like in even in the sentiment analysis, which,
I'm not getting it.
sorry,
I'm not getting actually
okay,
what it.
okay. So what I'm saying is there are two ways to solve this problem. If you have input text, you feed it to the model, and you will get some answer. Like the the model will say that the review was positive, negative, neutral, for example. So, in order to solve such case, we can approach this problem in two ways. Either we can convert this review into a number and use the existing models. Otherwise, we can find out other new models which can directly analyze the text. So, if you were given this problem, which approach you would take? Would you convert the review into numbers and use the existing model, or you will construct a new model and that wouldn't need you to convert this into kind of? So,
Maybe second.
okay. So, second is one that we will be using today, which is used in ML, machine learning. And your deep learning uses this method. Okay, those are completely different model. They also need a text to so word to vector, but that is a completely different model. So they have established new models altogether. So, but today we will be using this, as you said. We will be converting the entire text into numbers, and then we will use the existing classification algorithm. Okay? So before we so so now what we are gonna do is, so we will take the second path and we will solve the problem for sentiment analysis. So what we will do is we will take the text, we will convert that into numbers, okay, and then we will tell if it is positive or negative. Okay, this is the goal. So now before we even go to this like converting text to numbers, what we need to do is we will need to follow some pre-processing step. So even without pre-processing steps, you can convert the text into numbers. But what I want to tell you is, with pre-processing step, your complexity of the problem will be reduced to a considerably low level. So it is always better to follow some pre-processing step before you go dive into the actual problem. So the first pre-processing step is we will keep only alphabets. Okay, first thing is we will keep only alphabets. So if there is anything other than alphabets, we will remove it. For example, full stop, comma, question mark, exclamation mark. Then if you have smiley, so if review is like this, okay, then we will remove this smiley and other things we will remove. So basically, we will be keeping only the alphabets. Everything else other than alphabets, we will throw it out. This is the first processing step. Then second is we will convert everything into either uppercase or lowercase. So if you have words like this and food, only difference here is in first F is capital, in second F is small, but it will treat these two as a different words, because capital and small are treated differently in a machine learning algorithm. Okay? So what we can do is we can either convert everything either upper or lower case. Okay? So because this algorithm will treat it differently, so this is to make the model less confused. So either you convert everything into uppercase or everything into lowercase. Just a second, I'll just grab water and come. Okay, sorry. So either convert everything into uppercase or everything into lowercase. So this is a uh, second pre-processing. For pre-processing,
अगर
hmm,
if number is there in review, no need to convert. Huh?
no, we will remove those. If numbers are very important in the context, then we might need to think, but mostly even numbers we won't.
Okay.
क्योंकि क्या होगा कि फिर numbers there will could be infinite possibilities of the number. If you keep those, words will have like finite possibilities. Like average people can use like 3,000, 4,000 words or so, maybe more than that, but let's say 10,000. But if you think about numbers, there are so many possibilities that could be there in the text. So if we what we try to do is we try to keep uh, try to minimize the strain on the model. So that's why we are trying to. If if numbers are very important to the context, maybe, but that is also not advised. Keep only
No, like
words.
sometime someone write ONE1, someone write only one like in number numeric. So how it will identify?
Okay,
Like,
okay, got it. So for that, we have another way to identify the like if it's number or not. But anyways, if it is written in text, we will accept that. So that's why we haven't made it complicated. What we are saying is we will, take only alphabets. So we didn't say we will not take numbers written as ONE. Okay. Because as it is alphabet, we will take it. What I'm saying is we will avoid taking like numbers like written in numerical way, because then what we will do is we will unnecessarily complicate things. Did I convey it properly to you?
Yeah, fine, fine, fine.
So our restriction is only to alphabets. So if anything other than alphabets is there, we'll throw it out. Okay. Then the third pre-processing step is called stop words. So stop words, these are the words which we use in sentence or paragraphs, which does not have a strong opinion or sentiment in itself. Let me take an example. I love it. I hate it. Okay. Now here, I and it can be used in case of positive and also in case of negative sentiment. So these words have practically no contribution. Even if I just say love, hate, even then we will understand this would come from a positive comment and this would come from a negative comment. Okay. So therefore these words which have no contribution to the sentiment, those words we will remove. So the words like, for example, I, we, our, is, the, it, all these words which doesn't contribute to the sentiment of the sentence, we will remove it. So we will remove all these are called stop words, and we will remove all the stop words. So for example, loved, food, here. Okay. In this, can you identify this stop words?
I in the
Mm-hmm. Hmm. Here.
here, but here it represents the place name, no? But how is okay,
Yeah,
fine.
yeah. But even without this, you can correctly identify the sentiment, right?
Yes.
So then this is also not needed. So you're after you're removing all loved food. Even this will convey you the sentiment correctly. You don't need this I, the, and here. Understood?
Okay.
So we are basically doing this is because we want to reduce the complexity of the model to an extent where we can. And another thing is the lesser the words, more better you can make the, because already people will be using so many words in write while writing the review. So if you use if you can eliminate some words, then that would be better for your accuracy. And then another last pre-processing step. In this pre-processing step, what you do is find the root word. Let me tell you what it means. So let's say there are words like this: change, changed, changing, changes. Okay. These all comes from the same root word. Same root word, change. And inherent meaning of these is also same. So one only the tense is different. So one is simple present, uh, past tense, simple present continuous, and so on. So basically, inherently, the meaning of the word is same. The root word of all these words is same, and they want to imply the similar thing. Okay, so therefore, instead of sending all these forms of the word, what we will be doing is we will send the root word. So stemming and uh, lemmatization are two ways in which we can find the root word. So these are the two processes. First process, first is stemming, and second is lemmatization. Let's see the first, stemming. The stemming is the rule-based method. It is rule-based method. It has so many rules, okay? But let me just tell you two rules. So the first rule is if we see E, ES, ED, okay, or ING at the end, then remove it. So for example, changes will become like this, change, or whatever you will pronounce it as. The changes will become this. Even the change will become this. Okay. Then, so notice that E in the change will also be not present. Another rule can be that if Y at the end, then change it to I. For example, friendly will become friendly, Li. Okay. So the root word that stemming will give sometimes might not have meaning, but it serves the purpose. So instead of different form, it send the single word. But word might not have meaning, but when it understand the whole uh, text, like then it will figure out the meaning, because anyways these spellings are made for us, okay? And most of the part we do spelling mistakes, or we do uh, the past present tense or whatever would only be implemented at the last part. So majority of the rules deal with the last part, keeping this part intact. So these are the rule based technique. So there are different rules in stemming. We have mentioned only two. So is this part clear?
What is the reason to change those things?
Mm-hmm. So instead of sending, so think about it, okay? Let's say there are 10,000 words. Just let's say, for example, let's say there you have all four tenses, right? Now, if you send different forms of all these 10,000 words, you will end up with a problem that has 40,000 words. We don't want that. We want to have a lesser words. If basically all of these words, if inherent meaning is same, then why should I have all these words and have a problem with 40,000 words, where I should have restrict it to 10,000 words. Basically what we are concerned with is the sentiment, right? So the inner inherent meaning of this is same. Change, changed, changing, change, all implement that there is some change taking place. Now, as all of this have same inherent meaning, why should I have the problem that has all these four different kinds uh, of all these different forms are used? So instead of these different forms, we want to send a single word so that we can have restrict our problem to limited number of words. Clear?
That's
Yes.
fine.
So that's why we will be using this. Let me just tell you how many. So see, average on an average, people speak about 6,000 or 10,000 words. Okay, so on an average, a person knows about 15,000 words. Okay, think about it. If there are million views, it is more probable that you will have a problem with 15,000 words. Okay, 15,000 words. Now, if you use all forms of those words, then you will be ending up with at least 60,000 or so words. I don't want to increase the complexity. If I cannot decrease, that's okay. At least don't want to increase it. So what we will do is instead of using those all forms, we will restrict ourselves to the main or original form, such that you will such that you will um yeah so that you will have the meaning of the word, but you won't have all these forms. Yeah.
Yes.
Now another way is there to find the root word, that is called lemmatization. Okay, so it will give you the actual root word. So for example, you have seen, right, orthogonal. Let me take this as an example. The root word of this ortho means uh perpendicular, no, straight, I think. Yeah, straight. So this is the root word. Okay, so there are actual root words uh, in the dictionary. So even if you Google search, right, it will tell you the root word. So if I see the word, say orthogon, if you see here, see more, then it will tell you the original word was orthogonia, which means right angle. Correct earlier, it's not straight, it's perpendicular. Ortho means perpendicular. It will tell you what is the original word, even if you use just search orthodontist. If you just check this here, you can see the word root word. So basically, see, this search at root word will tell you each word has root word. It came from the Greek word or, which means straight or correct. So orthodontist or orthogonal have similar root words. So it will actually find the root word, and then it will take it from there. So what your lemmatization will do is it will actually find those root words, and then it will convert into that. What you need to do is identify those so you will have already a dictionary prepared. So what it will do is word and its root word. Okay, so you will already have the uh, prepared list or dictionary of it. So it will have the word, for example, changes, and the root word will be given, which is change. So like that, the list of the words and its root word will be given, and then what your like program will do is it will change all the words to its root words. Okay, so if we so which method to go for? So this particular method, lemmatization, it will it is a kind of a dictionary, so it will give us the correct words, and it will be more accurate in terms of uh, the meaning and everything. But it is a very lengthy process, and for this you need a dictionary ready. Okay, so if your dictionary is ready, go for lemmatization. If your dictionary is not ready, go for stemming, because it will be very quick and you can get the results in a few minutes. So let us now we have covered all the pre-processing steps. Now only thing that is left is to convert the text data into numeric feed. So so we will be doing that now. So any doubt till now?
Fine, fine.
Okay. So let us see. how to convert into. So let me show it without pre-processing. Now that you have understood pre-processing, so let me just take all the words, all the things as it is, and let me just show you. So let's say first sentence is I loved the food, hated, I hate, or I hate the food, I enjoyed place. Let me take these three examples. First thing you need to do is identify all the unique words. Okay? So in order to convert it to numerical features, first find out all the unique words. Let us see. The first word is I loved the food, ate, enjoyed place. Okay. Did I leave anything? I love food, ate, place. So instead of loved, let me take love. And instead of enjoyed, let me keep other things as it is. Actually, in the if we do proper pre-processing, we won't have this I, the, and all those things. But let me just keep it for time being. So, and then you will have the why. Okay. So think of this as training data. You will, as you already have the review and sentiment. So remember, this is supervised learning. So you have first few sample data prepared on which you will train the model, and then only you can use it for the testing. So first you have the label data of the review and corresponding sentiment. Okay. So all these, let me just tell you all these sentences, how to, let us see first how to convert it into the numerical data. It's very simple. So wherever there is that particular word, write. So first let us take this sentence. Okay. Wherever the word is there, write 1. If the word is not present, write 0. So I is there, I will write 1. Love is there, I will write 1. The is there, I will write 1. Food is there, I will write 1. For all others, I'll write 0, as those numbers are not, or those words are not present. And then the sentiment of this, I love the food, is a positive sentiment. So I will write 1. Okay. Now let us see for the second part. I hate the food. So I hate, love is not present, the is not present. Sorry, the is present. So 1 for the, then food is there, hate is there, enjoy and place is not present. And then this is a negative sentiment. Why? Third is I enjoyed the place. So I 1, 0, love, the 1, food 0, hate 0, 1 for enjoy, 1 for place. So then the sentiment so on. Now once you have all of these, then you just use your um, all the model, logistic regression, decision tree, and so on. And then you can convert, you can identify the sentiment. So it is not binary matrix. If something occur twice, then you have uh, so two, three, two times. So for example, if I say I loved food, but I hated the place. Let's say this is the uh, sentence. Here I has occurred twice. So when you are writing here, this is not gonna be 100 and so on. It's gonna be 2 1 1. So sorry, uh, yeah, 1 and so on. Okay, so this is not basically a binary matrix. This is here you will, if a particular word is occurring multiple number of times, then you will have that much count. This is called feature matrix. Each column in the feature matrix will be treated as one feature, which is one unique word. As it's a supervised learning, at first we will need to give the we will need labeled data, and we will need to give so we will need to give the sentiments for each sentence, and then we will need to train the model on that, and then only we can use for the new data. From this data we will train the model. While training a model will need y, so we, in order to train, we need both x and y. Here your x is the review or text basically, and your y is the sentiment, and that text we will convert to the numbers. So, and here your y is sentiment, so those also you will need to convert into numbers. For example, if it's positive, treat it as 1. If it's neutral, treat it as 0. If negative, treat it as -1. So you can choose that part. But what I'm saying is all these things need to be converted into numbers, and you will need both x and y in order to train, and then only you can build a model, because this is a supervised learning. And then we can do the classification using the algorithms that we have already studied, and use the algorithms like logistic regression, decision tree, random forest. All these you can use in this feature metric. So think about it, and let me know if there is any doubt, any part that is not clear.
Is that this model overestimate or underestimate this thing sometimes?
It can, true. But the thing is, uh, overestimate in which sense?
Let's say I wrote a 3 paragraph of
Hmm.
positive.
Uh-huh.
Sorry, one paragraph about positive and 2 3 of negative.
Okay.
So that time if it is takes a neutral, then how it is possible?
Yeah. So see, that's why I said there are many limitations of the machine learning algorithm. In case of such complicated, see, text, one sentence itself is complex enough for a machine. Okay. If you, for example, if you say, let us take this statement: I loved food, but I hated the place. So this is a positive comment or negative comment. Even for a human to understand this, did person like the place or not? Did the person like going to that restaurant or not? Means the focus is more on the food or focus is more on the place. Okay, right? Even for a human, it is a little difficult to understand. So, machine learning has some limitations. If you have so much complex data and full paragraphs reviews, so for example, Google reviews, they will write an elaborate, you know, elaborate review. Like, for example, if they are reviewing a movie, they will review the acting part, they will review the how good was the plot, how good was the ending, how good was the performance of each character, how was the character development. So there are so many things to write about. In such complex problems, your machine learning will model will easily get confused. So we don't use machine learning over there. Rather go for the deep learning up. But so majority of the use cases that you see have shifted already to deep learning because they offer a better output. But yeah, but it's like studying. Though we know the Rutherford model is flawed, we still study it because we want to see how basically we approach the problem. Just like now you saw, when I told you this, you saw the problem that it won't work for the complex data. You're right, it won't work for the complex, um, what to say, complex problems, but that is the thing. But for the simple and well structured data, it will work fine. Have I cleared your doubt?
Okay.
That is a limitation of this machine learning algorithm. We agree to that. But one thing is that this is the starting point, and even with this, you can get decent results. 70-80% accuracy also you can achieve. So,
I know this is example. This
uh,
is one of the examples only. But still, we can take the use of rating, no? Like
yeah,
three
yeah, yeah.
rating, four.
Yeah, definitely. So when you take this y, okay, here I have just given 1 or 0, but you can actually shift it to the cardinal rating, no? Like 1 star, 2 star, 3 star, 4 star, 5 star. Yeah, you can do that. Even what you can do is you can uh, classify the text into sad, happy, anger, all these things also you can classify the text into, but you need label data. If you have that.
No, I'm saying it's for
Mhm,
this example. Okay,
mhm.
this review example.
For
Uh,
this.
that apart from this review in text, there will be a
Yes,
number
yes.
in review. Let's say someone put 6 stars, 7 stars. It can most
Yeah,
of
yeah.
us are positive. One
Yes,
star, two
definitely.
star. Then we can generally we can say this is a positive, negative.
Yes,
So we take this that help and generally we can say no, this sentiment is positive or negative.
yes, we can. What I'm saying is using 2 or 3 words which are both positive and negative, like, so 3 positive words, 3 negative words will confuse the model. I'm not saying it won't perform at all. I'm saying in some cases it would confuse the model and you might compromise on your accuracy. But I'm not saying you won't get results at all.
Okay, fine. Thanks.
So it depends on the data. If you have so many examples like that with complex, your machine learning algorithm would be able to catch those. But if you, yeah, with fewer examples, if you train, it might not work well on the test data. That's what I mean to say. You, it's it would be easy for the machine learning to get confused and then give you the wrong result. Yeah. But yeah, you can try on the different complex problems. It's always, yeah, you can try and check if this approach is working for your data, because a lot of things are data specific as well. So if you try and it works, then it's fine, no problem. So then another approach is unsupervised. Actually, unsupervised is very easy algorithm. You will understand it very easily. So first step is you will get a pre-maintained database. So they will construct a database. They as in the SMEs, the um, industry experts or the subject matter expert. Those will construct a database such that each word each word has emotion assigned to it. For example, love will get +3, hate will get -3, and all the words that doesn't have any sentiment attached to it, you will get 0. So like that, they have constructed the list of all words, and they have given the emotions to each of the strong positive or strong negative. We will eventually so 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 if a word is strongly positive, it will have higher positive number. If word is strongly negative, it will has high like low, very low number. So mm, uh, ne- very high negative number. So the number will actually be very low. So to find the emotion of the sentence, so we can do it like this. So let's say, I love the food. Okay? Let's say this is the sentence. So if I have the emotions, how would you what you would do? How you will understand the emotions attached to this word sentence?
But
Mm-hmm. Sorry.
what your question?
So now once you have the database with words and emotions given to it. So for love, let's say it is +3. For hate, it is, let's say, -3. Okay. So now once you have all that, then how would you um, how would you come up with the scoring system for this sentence? So see, if you want to understand it's positive or negative, now you have the emotions given in the numbers. All you need to do is add them, right? So love is 3. Let's say the and food is 0, 0. Let's the total number is 3. Total score for this will be 3. If I say the same sentence but with instead of love, if I use hate, then it would be -3. So I can understand from the score that it is positive or negative. Clear? So first, the database will be constructed and it would be given to you. Okay. Now based on that database, just just calculate the score for each sentence. How would you calculate the score? Each associated emotion You sum those up. Take the
Yes,
sum of those. Sorry?
yes, I told you.
Okay. And then once you have the score, then based on that score, you will say it's positive or negative. Clear? This part, this,
Yes, yes,
sorry, you were saying something?
yes, yes, yes. Told
Okay,
you.
okay, okay. This process is called emotion mining. This process is called emotion mining, and the previous one was sentiment analysis. So yeah, so now with this, we will what we will do is we will take a quick break. Let's meet at 10 o'clock, and then after that we will do the coding part for this. We will be covering only this part of the NLP because
Is it emotion mining or emotion mining?
what is emotion? Sorry, not double M. No?
Yes.
Sorry, sorry. After this text suggestion, I am forgetting all the spellings.
नहीं नहीं इधर ही मैं सोचा इधर ही देखा है.
Okay, it's emotion mining. Okay. So then we will meet at 10 o'clock, and then we will do the coding for these two. Okay.
Fine.
Mhm. Okay, then we'll see you at 10. Use Collab for today. Okay. The thing is, it gives troubles for the Windows system. See if you can Collab. So first you open the. Let me just share this. Okay. So first, you open this NLP one. For this, you will need restaurant review file loaded here. Here you will need to upload. If directly drag and drop doesn't work, look at click here. You can click here. Look it. Let me know once you have the file.
मैं जुपिटर में ही कर रहा हूँ क्या प्रॉब्लम.
No. Actually, there is one library called Spacey that would give problem. Not in this notebook, next notebook, but this notebook you can run here, not an issue. But the next one, you would need to. Okay, let's see if you get an error. See. Okay, so you have all the files ready. इफ यार जुपिटर में कर रहे हो तो जहाँ पे ये जहाँ पे ये नोटबुक है उसी में ये फाइल भी होना चाहिए सेम डायरेक्टरी में. Let's then start run this. This is just to import all the libraries. Now here we are reading the file. Now this is TSV file. TSV file. So what is our CSV file? CSV file is comma separated. So two columns or two values are separated by a comma. Similarly, TSV file is tab separated. So it is separated by tab. So that's why we are providing, while reading, we are providing that here the separator is /t, not the usual comma separator. Okay. So now once we read this, this is how our data looks like. There are bunch of reviews, like for example, wow, love this place. So the reaction is positive. Then crust is not good, so reaction is negative. Not tasty, and the texture was just nasty. So this is negative review. So we have bunch of reviews. So we have 1,000 reviews, and we have the positive and negative both. Okay. So now first what we will do is we will do the pre-processing. Now in order to pre-processing, we will be using this library called there is this library called RE, which stands for regular expression. We'll be using that. What we are trying to do is we will be so here this uh, so the review is here is column name, and dot re dot sub, what it does is substitutes sub stands for substitute. So if we get to see anything that does not belong to uh, a small a to z or capital A to Z, it will simply replace it with null. So whatever we want, we need to mention in the box. Anything other than that, it will throw it out. Now make sure that you have this cap beforehand. Now you see, this is my sentence. If I use this cap, only A to Z, capital and small, so only alphabets will return, everything else will be thrown away, right? Like this semicolon, this exclamation marks, everything is thrown, only the words alphabets are there. If I forget to give this, it does complete ulta, complete opposite. So it will only keep the exclamation marks and semicolon and throw all the alphabets. Make sure you have this at the start. So it will tell you throw everything except this. And if you don't give this, then it would understand through this, keep all other things. Clear? So first thing what we will do is we will then okay. So now so you have these two columns, review and reaction. Now you have only alphabets in. You do not have any numbers, exclamation mark, full stop, comma, semicolon, anything. Everything else is removed because we have asked the library to keep only A to Z of all the values from A to Z and capital A to Z. So whatever we need to mention in the box. All other things would be thrown out. Now the next step we will do is we will apply this. So what we are trying to do is we will convert everything into lowercase. So can you see the C is capital, N is capital here, S is capital, T is capital, W is capital. So first letter of all the sentences is capital. So now what we will do is we will convert the entire text into the lowercase. So what we have now is all the lowercase values, all the lowercase text. Okay. So this is the second preprocessing. Now we have the data where all the things other than alphabets is removed and we have all the text in lowercase. Now what we will do is we will remove all the stop words. So in order to do that, we will download first all the stop words. Now you see here we have the we need to have the pre-defined list of all the stop words. So first we will download all that. So we will download the stop words. Then you can see here for English, these are the stop words. Why, that, the, r, re, no, nor, me, and something. All these about, above, after, all these are stop words. So we will remove that. Even for some, so there is one interesting thing. There is a English. Hindi is not there, but English is there. And here you have wahi, वैसे, wala, wale, and all those things. Okay, so these are the stop words which you will remove before we start with the actual text analysis. Here, okay. Now, now we are till the we have completed first three pre-processing steps. So now what we will do is we will first now we need to find the root word for each word, right? So in order to find the root word for each word, first we will split the sentence into the words. So how we will do it? Simply we can use dot split. It will give you a list of all the words. Okay. Now what we will do is we will iterate through this list. Okay. We will iterate through each of the list and see if it's sorry. This is for the stop word. So we will iterate through each of the word and then we will see if that word is a stop word or not. If it's a stop word, we will remove it. If it's not a stop word, we will keep it. So for each word, we will check if this word is stop word or not. If the word is stop word, we will remove. So first we will convert the sentence into the list. We will iterate through entire list, check if that word is not present in the list of the stop words. If it's present, we will remove it. If it's not present, we will keep the word. And that way we will have all the words, stop words removed. Okay. Now we will do the stemming. Okay. So we will import, we will call this porter stemmer. And then if you pass the word here, run this first. What it gives for the change. Okay, it has removed the E. If you see for so basically it has some rules. Okay, it will change it according to those rules. So same thing we will do. We will apply the stemming for each word. So as we have already converted uh, the sentence into words, so on the each word we will apply this stemming stem stemming algorithm. So instead of the word, now you will have the root word for each word. Now once you apply this, now you have the list like this. Then now again we need to convert it into the sentence. So just do use the separator that you want to join the words with, and then just do the join and pass the. So if you do that, you will get all the words joined with the separator of the uh, with the separator space. Okay. So similarly, you do that for each list. So on the each list, you apply this, then you will see that those list is converted now into the sentences. So go through the notebook till here, till the block 28, and then we will, if there are any doubts, just let me know once.
This can remove not also.
Mm-hmm.
Like something. Go to the
Which where?
not on this trust good review. Second one is
Rest good.
this is actually not good. This remove not also.
Okay, okay. Yeah, it can do that.
Then this is reaction is zero, but
Yeah.
look that's good.
Yeah. It shouldn't. Now the entire meaning is changed. Here also they did this. Not tasty texture. They made it tasty textureness. That's the limitation. This pre-processing. Yeah. Then you will need to alter the top. You can see that if word is not in stop words and not. Okay, and then the next thing here, we are just writing entire steps as a function. So we don't need to repeat the whole thing again and again. We can just convert this into a function. Just pass your text in this function, and then it would do all the things. So it will remove everything other than this smiley will be removed. Anything other than the text would be removed. Then it would convert everything into the lowercase. Then it would split it into the words, and then those words will be checked for the stop words. And we will find the root word for all those words. And then again, we will join it, and then the final sentence will be written. Okay. So all these things would be done. Then yeah, so all those pre-processing is applied. Now all the things that we have uh, seen is this. So all the till now we have done just the pre-processing. Now we will see how to so we as we saw how to convert the text into the to numbers. So we will be doing that. This is also this is called count vectorizer. So what we will do is first we will list out all the unique values, and if your value is present here, you will write 1. If not present, you will write 0. So like that you will get a vector for each sentence. Each sentence you will get the vector. So let us take example here. There are 3 sentences. The sun is shining, the weather is good. The sun is shining and the weather is good. So now in the first set the you have sun, you have is, you have shining. Everything else is 0. In the second set you have weather, you have is, you have good. Okay. The weather, good and is. Everything else is 0. Okay. And in case of third sentence, you have the 2 times, is 2 times, everything else is 1 time. So 2, 2, and all other things are 1. And these are the vectors that you got. Now in the
middle में dot क्या है?
that just I gave. It's just I gave while writing. Okay. So then another example could be I just gave it so that 0.0 like that. Ignore this.
Fine.
Then the second set of examples say we have these three sentences. I love the movie. I hate the movie. And Vijay was good in the movie. So we will identify all the unique words. I love the movie. So I love the movie. All these values 1, everything else is 0. This is the vector. Then second set, I hate the movie. All these will be 1, everything else is 0. Vijay was good in the movie. Vijay was very good in the movie. Everything else 0. So you can just see here I have made array of these three sentences, and if I do the count vectorization, it will count each word. It will first identify unique words and it would count how many times this word has occurred. So you can see uh, the first sentence, the sun is shining. So and is not present, so 0. Good is not present, so 0. Is present, so 1. Shining is present, so 1. Sun is present, so 1. Weather is not the is present, so 1. Weather is not present, so 0. Like that it will do for all these three. This is called count vectorization. Now we will do it for our data. So tem reviews, so we have these values. Wow, place, love, place, crust good, tasty, texture, something. So we have this pre-processed reviews. Okay. Now what we will do is we will apply the count vectorization on our data. So we will do it for the actual data, and we will generate the so now we will be doing for our data. Now it will show you the that are for all, each word how it will. Let me. Okay, so now we have the words and corresponding to vector for. So we have first identify all the unique words, and then you can see here there are 1609 unique words. So for each sentence, so each sentence will be of the length. So there would be one row and 1609 columns. This would be the dimension of each of the sentence vector. Now you have this. So the total, as we have 1000 sentences, so we have 1000 rows and 1609. Now we will split it into testing and training. So just like we used to do it before, we will split the data into training and testing. So this is what train data looks like. Then so test data is, we have kept the 70% data for the training, 30% data for the testing. Then we will train a decision tree model. So you see there is 77% accuracy for the logistic regression, 75% accuracy for the decision tree classification. Then so so we got once we train, we got this much accuracy. So it will give you predictions like this. So this absolutely is present. Uh-huh. हा नंतर करूया मग. Mhm. So yeah, so we will divide the data into training testing. We will train the model, and then now we will use the supervised model on the data. So once you train the model, you can use the model on your test data. So then you can get the predictions like that. So for the word that would be present, to show you the so actually you will be getting a vector like this. Let me just print the I can't go through see for this. I will check this part. Okay. Uh, just go through the code till now and just let me know if you have any doubt. I was doing a simple mistake. Anyway, so you can see here the prediction for the review ambience perfect gave the reaction 1. Let us check for a few more. See what this 350. At another 10 minutes, finally gave left. Maybe this guy sat for 10 minutes, didn't get food and left. So the reaction is correct. A C. Found place acid.
Accidentally.
Okay, accident. Nice. Found place accidentally could appear. What was? Let me think. Okay, I found this place by accident. I could not. Me. Let me see the other review. It read 8. Must have been an off night at this. So it looks like a seems okay. Okay. I haven't. Let me just see here. 625, right? 625. And so the actual is 1, predicted is also 1. Let us see. The second is 350. The actual is 0, predicted is also 0. See, it was decent job. 32. Okay. 32 is I found this place by accident. The actual is 1, predicted is 0, because see, this could be that this is complex, like accident and stuff like that. Maybe that's why it thought it's negative, but actually it's positive. We can see 1. So 208 third review. So the predicted is negative, actual is also negative. So this is a straightforward negative one, which is easy for the machine. Okay, go through the notebook. Tell me if you have any doubt. Okay, any doubt?
नहीं लग रहा है.
Huh?
डाउट है, नहीं लग रहा है.
डाउट है नहीं, क्या बोल रहे हो?
नहीं, ये बोल रहा हूँ, इस मशीन को थोड़ा अंडरस्टैंड में फील हो रहा है. रिएक्ट हो रहा है.
ओके, तो कौन सा पार्ट क्लियर
नहीं नहीं,
नहीं?
डाउट है, नहीं लग रहा है.
Now I'm confused. You don't have doubt or you have doubt?
हाँ, ये डाउट मतलब देख रहा हूँ.
हाँ, ओके.
डाउट है, नहीं लग रहा है, मतलब क्या बोल.
Okay, this kind of things you should not test on the machine. Okay.
जैसे टोल्ड ना.
Okay, fine. So I think you meant to say you don't have doubt as of now.
हाँ ये.
Fine, fine.
So you explain that what is it?
Mhm.
Forest, is it random forest?
Random forest.
हाँ. हाँ?
Sorry?
एक्सप्लेन किया है क्या रैंडम फॉरेस्ट?
हाँ,
कब किया?
you were not there.
आई एम नॉट
So,
देयर.
no, I don't know. I'm asking you. You don't remember it? Like, so what we do is
थिंक आई एम नॉट देयर, दैट्स
decision tree.
व्हाई.
In the decision tree, what we do is,
नो नो, just tell me
हाँ, so in
when you
the,
use this thing.
yeah,
I will see the videos.
हाँ, so bagging and random forest we covered together. So in the random forest, what you do is you in the bagging you basically choose the rows. Okay? In the random forest, along with the rows, you also choose the columns. Go through it once.
Yeah,
Go through the video once.
because this random forest,
Mm-hmm.
that in that conference, lot of people did it through random forest. That's very.
Yeah, it's very useful algorithm. Very useful. A lot of data you can. So there was one project. The data was also complex, but so we were doing one project for the prediction. So the kind of timetable preparation for uh, the housekeeping task. So we just use the random forest, and now it is like automated whole thing. So there are so many use cases of this if you use it. Even for your own data, you can use it for so many things. Random forest you can use, PCA you can use. A lot of papers are there where they use for the sensors mostly they use PCA. And now there is another notebook, hopefully traceable. Now you ask one question. You remember? How would you know if I write number one as a ONE and not as an actual number? So now you will see that how to do it. It is called name entity recognition. It will identify, for example, if it says Excel, it will identify it as a product. It will identify this as it has
Okay.
identified as organization. 2 as cardinal means number or numeric. Then this uh yeah, after 1 month after, see, it has identified it as cardinal. Okay, so let us do that. First, run this and tell me if there is any error that you are getting. The first cell, you run that and tell me if you are getting it. The first
That name
cell,
didn't say. Okay. One second.
ah,
ऐसी कुछ लैंग्वेज मॉडल.
ah, error आया ना?
हाँ.
Write and collab.
No module for named species.
Then do one thing. First, you do this. Write pip install AC. Maybe you use a specific version. Let's say 0.3.0. Try this.
Okay.
Try running this first line. Also install word cloud. I think will also pip install word. It get installed.
This
Hmm. Can
didn't run successfully.
can you show your screen? Share your screen.
कौन सा इसमें ये भी तो नहीं था. Pip install.
Share your screen then. Okay, go down. Last. Go to the last. Uh, go up, up, till down. Wait. Mhm. it doesn't have compilers.
Compiler.
It cannot import all these compiler packages are not. Okay, do one thing. Go to the collab, run it in the collab. Actually, it requires all those C, C++, all those packages. You install that from the VS Code.
VS Code है मेरे पास VS Code है.
But we will need to identify the packages and we will need to install all those packages. But instead of that, just try on the collab. If it doesn't work on collab, then we will troubleshoot. You can share the screen actually. If this runs, then all other part is okay. Now import your notebook. Go to the file, upload notebook, browse.
Yeah.
Yeah, browse. Sorry. Can you present again?
Sorry.
Can you present again? Okay. Hopefully it will be installed. Okay, perfect. Now go to that folder icon. Folder icon is there. Down.
Yeah.
Click there. There is upload button. Click there.
Comparison.
Apple.txt, and there would be another file called AFF.
WhatsApp में भेजना है. NLP. नहीं.
No. Apple.txt. Affine and Apple.txt both you upload. Okay. Perfect. Now you will need to change the path over there called the apple.txt. So it would be content. You can just copy the path of this. Click on the folder icon again. Click on that folder icon.
Here कर सकते हैं.
Yeah, you can edit it directly, but yeah, you can content.
कर रहा हूँ.
No. That's what I must. No, don't do it that way. Your collab doesn't have this path, no? So you do click on that folder icon.
Okay.
Go to that file. Click on those three dots.
Okay.
Copy path. Okay. Now paste that path there. Yeah, your collab doesn't have access to that local. Complete the colon. No. Complete the colon both sides. Both side there would be colon. Sorry.
Colon.
It's called? No. Not there. After the txt.
Here
Dot
only.
txt. Now you run this.
ये कुछ हो गया.
Okay, perfect. Okay, now I will share my So first, once you so once you have the file loaded, what you do is you pre-process the thing. So first you remove all the so this dot strip, what it does is it will remove the leading and trailing characters. For example, dot 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 dot, or like not dot dot, but extra spaces and other things it would remove. Okay, so you will have little cleaner text. Now this would remove all the empty strings. So then then you have this text. So this text is nothing but the product review. Like for example, let us read a small one. Okay, I'm very upset about the product. I checked my MacBook 15 days. I checked my MacBook 15 days back in December. It didn't start. It was luckily in the warranty. I took it to the service center. They informed me motherboard and battery collapsed. So it was not in the if it was not in the warranty, I would have to pay this. And I asked for the replacement. They refused. It got fixed for me and so on. So basically, they have purchased the Apple product, and for that Apple product, they are giving the reviews. So whatever their experiences are and how they felt about it. Now see here, there is no Y column. This is a non-supervised, unsupervised learning. Okay, so there is no Y column. Only reviews are there. Okay, so now we will be importing the speech tagging. Speech tagging is like just like you said, for if I write ONE1, how would I identify? So for that they use speech tagging. Speech tagging, what it will do is it will tag that particular part of the speech as with those particular types. So I don't know what this NORP is, but this MS, it is recognizing it as organization, and then Excel as a product, and so on. Okay. So then, uh, so once we have this, so till to go through the notebook it till here, and we'll take it forward. So basically, what NER does is it recognizes entities like ordinal or number, then product, organizations, etc., like all those things. Then NER recognizes names and other entities as so. Uh, there is another one that is POS tagging. Tagging. So it identify if the word is noun, verb. So it is called part of speech tagging. So it will, so each word, uh, it will identify if it's noun, verb, or so on. Then
एक बार बोलो ऊपर से, मैंने देखा नहीं।
uh, so so okay, you can see here this one. This is uh, NER. So n- natural entity recognition. What it will do is, the part of the speech, it will recognize the entity of it. Entity as in it is a name of a person, it's a corporation, it's product, it's date, it's cardinal. Cardinal is nothing but number. So like that, it will identify the part of the speech. Okay, and it will give the tag. So you must have seen for the photos they give tag, right? uh, the name of the person you can tag. Similarly, it tagged the part of the speech as with the entity. Like, for example, this Excel is tagged as a product. This is, they thought this is the organization. This Excel page is. So it might not be correct every time. Just like here, 2 is cardinal, which is correct. 1 month is cardinal, partly correct. This is cardinal, this is correct. JP, I don't know what is it. But yeah, so what it does is uh, it tag the part of the words of the sentences as a particular entity. Now there is another type which is called POS. POS is part of speech tagging. So for example, each word, it will identify it as noun, verb, adjective, adverb. Like that, it will tag it as a part of like speech. So so what we are doing here is, so NER is basically to recognize the entity. So it is like name or any other entity. So like that, POS is tagging, which imply part of speech. So they have rule based, and so some use, so it can be rule based as well, and there are some which do tagging based on the deep learning. Okay. So let's say we have a research paper and we want to find out all the names of the medicines used in it. So in such cases, we can use NER. Or if we um, mm, it's kind of like in the abstract, we write the keywords, right? In the most of cases, we write keywords. So similar things like we will be, or the best example is Instagram tags or things like, we give the tags, right? So similarly, it gives the tag to the uh, part of the text. Okay? So yeah, so we will give, it will give the entity for the part of the text. So now here what we are doing is same thing. We will just do the vector count vectorization. Then it will identify all the unique words and the count of those. We have done it only for the yeah. So, so yeah, so we have just printed the first 10 words and count for those. So we have done the count vectorization, and then we can see that different words, how many times they have occurred. This is just the bar chart of the words against the count. then we will see how to do the emotion. Now, as I told you, right, for the each word there would be assigned value. This is just one example of entity uh, recognition. Okay, just go through it and you will understand what it is. Uh, in in case of question, I will just explain this and then we will take the question. So, in for the emotion mining, I have this file called
తప్పిందా
uh,
వాట్సాప్ పడుతుంది
let me just download. So, if I show you few things, okay, you can see yuck, yummy, uh, dead, abandoned, aban, abandoned, abducted. All those are abduction. All these are negative words. So it has negative value. Now what we will do is we will remove the
what
just like
minus 20 gets
minus.
so
So this is the word and corresponding value. You remember we said
that's
love.
minus 2 is randomly given or like
Yeah, so
any reason to take minus 2 I
so
mean
for
2
basically for the negative words it will give negative value. How they do value, it's kind of like some people will like the kind of SMEs, the subject matter expert or the linguist, they will give the. So I don't know how this data is prepared, but usually the subject matter expert will
okay.
or the prepare the data set. I'm not sure exactly how they give the value.
Then
Yeah, that's yeah, we need to check that. I'll check that and I'll get back how exactly they give the values. Okay, so now what we are doing is we are first importing the bunch of libraries, and then what we will do is we will read that apple.txt file, and then we will remove the any there if there are any leading or trailing characters, we will remove those, and we will remove the empty strings as well. So once we do that basic pre-processing, we will just mm, okay. So now we will mhm. So, mm, okay. So let me first explain this part, the tokenization. Okay. So what we will be doing is we are using joining because we are not giving the sentiment for each review, but rather we will extract the sentiment from the review, and then we are going to find the emotion for the each. So basically, what we will do is we will first join it, and then uh, we will break it into the sentence, and then we will check the okay. Let me go here. This so this we will break it into the sentence. Then for each sentence we will try to find the value. So okay. So you see here this part, tokenize. This will break the entire text into small sentences. Like this, we will get the sentences. Now, we will be using for each word. We will see the score for each word, and then we have just written the function here to calculate the score. So for each word in the sentence, we will identify the score based on this affinity score affin.csv file. From that CSV file, we will find the score for each word. Okay, and then we will sum all those words. So, for example, if you have this, let me so for example, the text amazing has the score 4. You can tell me any word. We can just check any word coming into your mind.
Magnificent.
Uh-huh.
Magnificent.
Okay. Magnificent is not, maybe not in present, or it is neutral. It is maybe it's not present. That's why it gives.
Great, great, great. Excellent.
3. Okay. So like that, for each word, they have given the uh, for each word they have given the scoring. Okay. So we can check for the okay. You can check small. Okay, let me just pass this. I am very big, and I am. Let me just pass. I will have 0. M will also have 0. Very will also have 0. And happy will have 3. So if you count all that, you should get 3. If I proud will have 2. So let us check. Very happy and proud. That's it. Then you should get 5. Clear?
Yes.
Yeah. So now we will implement this on all the sentences. So you will get, so there are total 12 words, and sentiment count is 5. There are total 10 words, sentiment count means I am, all those things will have 0 sentiment, but only happy, great, sad you can check. So we'll have minus. Okay. So you see, sad has -2, proud has 2. So addition of that would be 0. So like that, we will calculate the sentiment value for each. Now see, this is strongly positive. Okay? You can
वो
see
क्या
here.
गाना गा रहे थे क्या एप्पल एप्पल
उसको ही पूछना. Then we have just plotted it, the sentiment value and okay, we got 5K in Diwali sale. There is no sentiment here. That's why sentiment value is zero. All printers are not compatible. So there is no sentiment. So the words are there, but here you see problem will be there if you are switching from some. Overall, it's negative sentiment. Like that, it will basically identify the sentiment. Go through the notebook and let me know if there is any doubt in any part.
ये एनएलटी की क्या है
It's a library. So, it is used for the token, also for the
डिफाइन नहीं किया हूँ पहले।
आप just write import NLTK above this. Write import NLTK. NLTK is library that used for a lot of things like stemming, tokenization, parsing the image, tagging.
और इसका भी चार है
Hmm?
सेंटिमेंट
Ah,
इंस्टाग्राम का
yes, yes.
अमेजिंग अनी sorry, density मतलब क्या होगा?
Let's
Zero is around having the point more.
just know. Majority words are of the zero
Okay.
sentiment. Okay. There are very less, very less. Sorry, majorities. Yeah, there very less are there with such high sentiment value. The
Point ये numbering कैसे हो? 0 to 0.3
sorry. Okay, percentage.
percentage.
You can see this one has very high sentiment value, 24. That's here. And here we have printed, okay, which has sentiment value greater than 20. You can even see there are only two with greater than 10. Greater than. So there are two values with greater than 10. You can even see that there are so many values with equal to 0. So is equal to 0? Yeah. Okay. Let us check. Equal to or near 0, also so many values. Yeah. So many values will be there. To see there are total 63 sentences with uh, sentiment value 0. Okay.
Oh.
So you can check all those parts. Any doubt?
No, fine.
We will for the day. Tomorrow, we will need to leave early, so we will take it only for 2 hours, 8
Okay.
to 10,
Okay.
or if yeah 8 to 10. Okay, then we'll see you tomorrow.
Yes. Okay.
Good day.